All right, today in math, we're going to discuss multiplication, and we've really kind of discussed all these things. We just can't talk about them enough. It's important that you understand what multiplication is so that you can do it a little bit better. All right, now, speaking of multiplication, I did throw in a couple of multiplying by threes timed tests. Obviously, we're not timing these, but if you want to try to figure out those, go ahead. When you get back Wednesday, we are going to be doing a number of things. One of them is going to be talking about multiplying by threes and how we can count by threes to help us out. Then we'll also, because if you notice, we already have something that's in bold, and we will, and if you notice, there are quite a few pages that things we'll have to put into our dictionary. We'll get those in on Wednesday too. Okay, so don't worry about that you don't have those things in yet. We will take care of that on Wednesday when we're back to school. Yay! Okay, now if we think about multiplication, this says hands-on, modeling multiplication. So if you want to go get just some things, they don't have to be these kind of counters like he has. It could just be anything that you have a whole bunch of, all right? If you want to do that, you can, but we kind of did this at school one day already, all right? Now, let's think of one way to think of multiplication. When you have equal groups, you have the same number of objects in each group. Use repeated addition to find the total number of objects. Now, multiplication requires that all the groups that you're putting together have the same amount in them, okay? Because you're really just adding the same number over and over and over. In this way, multiplication isn't anything new. It's just repeated addition. That means you repeat the same number over and over and over. Okay, this says use connecting cubes to show 4 equal groups of 5 cubes. Now, I don't necessarily even have to have anything like that. You could just use a piece of paper. And if I want to show 4 groups of 5 cubes, here's what I would have. Here's one group: 1 cube, 2 cubes, 3 cubes, 4 cubes, 5 cubes. And if I do that 4 times, that'll be 4 groups with 5 in every single group. Now, if I had my little blocks, that would have gone a little faster, but I know you guys didn't have them, so I didn't want to use the blocks if you didn't get to use them either. All right? But there's my 1, 2, 3, 4 groups with 1, 2, 3, 4, 5 in each of my groups. So this would show a multiplication problem that we'll get to in a second. Now, if I didn't want to actually make the cubes, I could do this. Here's one group, and this is kind of how we did it the other day, if you remember. There's my 4 groups, 1, 2, 3, 4. And I have to put 5 in every group. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right? So both of these things show 1, 2, 3, 4 groups, and 1, 2, 3, 4, 5 in each group. Okay? 1, 2, 3, 4 groups, and then 5 in every group. Now, if we look back at the book, it says, if I can find my pencil, where'd you go? There you are. It says there are blank groups, well, 4 groups, with 5 in each group. This is something I'm going to be very particular about, so make sure you pay attention to how this works. Write the number of cubes in each group. Use repeated addition to complete the number sentence. So the number of cubes in each group is 5, isn't it? So I'm going to take 5 and add it together 4 times, because there's 1, 2, 3, 4 groups with 5 in every group. See how that works? So the total would be 20. And I bet you can count by 5s. 5, 10, 15, 20. Okay? Now, down here it says record the number of groups, the number in each group, and the total from above. Explore other ways to group the 20 cubes equally. Aha, okay, we're going to do a little bit of exploring here. One way was to make 4 groups with 5 in every group. Now, if I had exactly 20 things, this time I'm going to do it a little differently. I'm just going to make 20 X's. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I could do this. I could go, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, there's 2 groups with 10 in every group. Or somebody else might have done this. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. In this case, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups. And I've got 2 in each of my groups. See that? 1, 2, 1, 2. Here's an important thing, though. They are equal groups, aren't they? Every group has exactly 2. I have to group it that way. So if we look back in our book, they said, well, you know what? I could take those 20 counters and I could do 10 groups, putting 2 in every single group. Now, watch what I'm going to do, because we're going to learn a name for this. See how we did 4 groups with 5 in every group? I wonder if I can do what I do with addition. Because multiplication and addition are closely related to each other, I wonder if I can use that commutative property and flip them. So instead of 4 groups with 5 in every group, let's try making 5 groups with 4 in every group. Okay, so 1, 2, 3, 4, 5 groups, and I'm going to put 1, 2, 3, 4 in this group, 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 1, 2, 3, 4 in this group as well. I wonder if that's actually going to be 20. Well, I can count them. 1, 2, 3, 4, 5, 6, 7, 8. I can do that. I could count by 4s. 4, 8, 12. Yeah, but you might get lost counting by 4s right now, right? That's kind of a hard one to count by. I bet somebody's saying, you know what? I can see groups of 2 inside all these. Let's count by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Hey, there are 20. So I could do 5 groups with 4 in each group. That would give me 20. Well, hey, guess what? If it worked here, I think it would work there. Could I do 2 groups with 10 in each group? I bet I could. Let's try it real quick. 2 groups with 10 in every group. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's a group. There's a group. 2 groups, 10 in every group. And this is the best part. Watch. 10, 20. I can count by 10s. You can count by 10s too. 10s are easy. So guess what? 2 groups with 10 in each group would also give me 20. So there's different ways to be able to get that same total number and doing different multiplication problems. All right, so knowing that it's equal groups is an important part of knowing what multiplication is. Okay, go to the next page. I have to kind of move my things a little bit so I can get to my next page. The next page actually looks like this. Okay, this is page 194. See it down there? 194. Okay. All right. At the very top, we've got a whole bunch of words that we will eventually put into our dictionary. We've got multiplication, multiplication sentence, and multiply. But we'll do that on Wednesday. All right. Here we go. Ooh, it's getting windy. I'm on my porch doing this. You might be able to hear that. This says, you can also use multiplication to find the total number of objects in equal groups. A number sentence with the symbol, it looks like an X, is called a multiplication sentence. It means multiply. So when you see that symbol, that X, it means you're going to multiply. And I think you all already knew that. All right, let's look at this one. Sean helped his mom bake cookies. He served 4 cookies on each plate. There are 2 plates. How many cookies did he serve? Well, first, I'm going to model that. All right. So it says there are 2 plates, and there's 4 cookies on each plate. So I'm going to make a plate and a plate. Okay. Now I'm going to make 4 cookies on each plate. Now, to figure out how many cookies he served, I can just count these, right? So I can just go 1, 2, 3, 4, 5, 6, 7, 8. There we go. There's 8 cookies. I could also use repeated addition to complete a number sentence. Well, I've got 2 plates, and each plate has 4 cookies. So I could just say 4 cookies on one plate plus the 4 cookies on the other plate. So 4 plus 4. And you know your doubles well enough that you know that's 8. Or I could write a multiplication sentence to show that 2 plates of 4 cookies, or 2 groups of 4. Now, this is where I'm going to also be very particular. The number of groups is 1, 2. There are 2 groups. There's going to be 4 in each group. So for now, I'm going to be really particular about which numbers you put in which spots. Eventually, we'll get into the commutative property like with addition, and it won't matter. But right now, I want you to always think of this first number you write as the number of groups, and this be the number in each group. So 2 times 4, 2 groups with 4 in each one, would also equal 8, wouldn't it? So he served 8 cookies. All right? Okay, look on to the next page. We're going to use that same idea to do a little more stuff like this. It says, draw a model to find the total number. Now, remember, the idea is that we're getting the understanding of multiplication to be real solid in our brains. Okay, this isn't something you would always do to multiply. But we want to practice making the pictures so that we know exactly what multiplying is. Okay? So if I make a model of 6 groups of 2, I like having a comma here. 6 group of 2 equals, well, I need 6 groups. 1, 2, 3, 4, 5, 6. And I have to put 2 in each group. 1, 2, 1, 2. 1, 2, 1, 2, 1, 2, 1, 2. Now I can just count on my 2's. 2, 4, 6, 8, 10, 12. So 6 groups of 2 is going to equal 12. Look at this next one. 3 groups of 5 equals, well, I got 3 groups. 1, 2, 3. There's 5 in each group. It's 3 groups of 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And if I count them up, 5, 10, 15, that would give me 15. Let's do it this way. 2 times 4. Let's make the picture of that. Now remember, I said I was going to be particular. This is the number of groups. This is how many in each group. So 2 would mean 2 groups. 4 is how many are in each group. And if you remember from the cookie problem, that's the exact same thing, isn't it? So 2 times 4 is still going to be 8. 1, 2, 3, 4, 5, 6, 7, 8. Look at this one. 1 times 7. That means I've got one group, and I'm going to put 7 in my group. 1, 2, 3, 4, 5, 6, 7. Well, if I only have one group, and there's 7 in that one group, then the answer is going to be 7. Oh, that's going to lead us to another property of multiplication we're going to learn about. Okay, here we go. I'm going to describe each set of equal groups. So look, here's a group, and here's a group. They are equal because they both have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 in each group. Well, let's see. If there's 5 in each group, and I put the two groups together, I'm doing repeated addition, right? So it's 5 in one group plus 5 from the other group. And that means that I've got 2 groups of 5, and that equals 10. So that's what this picture is showing, that there's 1, 2 groups, there's 5 in each group. That will give us 10. Look at this one, you got paper clips all connected. It looks like I've got 1, 2, 3 groups. I kind of like doing this first, to be honest with you, the bottom one. Well, how many are in every group? 1, 2, 3, 1, 2, 3, 1, 2, 3. There's 3 in every single group. That's good because I can do repeated addition if there's the same number in each group, okay? So that means that I would have 3 in my first group, 3 in my next group, and 3 in my last group. 3 plus 3 is 6, plus 3 more is 9. Okay? All right. 10 and 11, we're actually thinking about it a little bit differently. They're giving us it as a multiplication problem, and we have to say what that would be with the groups. So 8 times 2. Well, that means I have 8 groups of 2 in every group. Well, if I make a picture of that, here's my groups. And now I'm going to put 2 in each of my groups. That's what it would look like as a picture. And if I have 8 groups with 2 in every group, it would be 2, 4, 6, 8, 10, 12, 14, 16. So 8 times 2 would equal 16. All right, let's look at this one. 5 times 5 means that I have 5 groups of 5. So there's 5 in every one of my groups. So if there was a picture, and it doesn't say I have to make a picture for these, but I just like to look at it and see what it is. There would be my 5 groups, and now I'd have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I put 5 in every group. Now I could just count all of them, or I can use a repeated addition. 5, 10, 15, 20, 25. So 5 times 5 would give me 25. Okay, look at this one. It says equally group the counters. Draw the equal groups. Okay, a set of 6 counters. Okay, so if I've got 6 counters, 1, 2, 3, 4, 5, 6, I'm going to group them into equal groups. So I could do it this way. That's one way I could do it. I could make it as 2 groups of 3, which is the same as saying 2 times 3. 18 counters. 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, the way I did it this way, I could do this, right? Where I had 2 groups of 9. But I could just as equally have done this. I could have done groups of 2 and had 9 groups of 2. There's other ways I could have done it as well. Maybe some people did this. There's 18, and I have 6 in each group if I have 3 groups. 3 groups with 6 in each group. So there's lots of ways that you can kind of regroup things in order to put them together. The idea is, though, that they all have the equal number in each group. Okay, they have to have the same number in every group. Okay, we're going to do a couple more, and then I'm going to give you your assignment. Right here, it says that we're going to draw to complete each model. So watch. Tennis balls come in cans of 3. How many tennis balls are in 4 cans? Well, cans of 3 means there's 1, 2, 3 in every single can. All right. How many are in 4 cans? Well, I've got 4 groups with 3 in every group. So that means that I'm going to add together the number that's the same in every single group. That's the 3. And when I add 3 together 4 times, I end up with 12. And we're going to practice counting by 3s on Wednesday. Look at this one. Sam has 2 celery sticks. Each stick is topped with peanut butter and 4 raisins. How many raisins does Sam have in all? So I'm going to go 1, 2, 3, 4. 1, 2, 3, 4. Now remember, the hard part isn't necessarily knowing how many raisins. It's thinking of it as groups and a certain number in each group. Okay? Good old ants on a log, right? Well, he's got 2 groups, and there's 4 in each group. So here's my 2 groups. I'm adding 4 together twice. That means he has 8 raisins. Again, knowing that it was 8 isn't the hard part. It's making sure you can understand how to think of multiplication as being equal groups. Okay? All right, look at this. Mary bought a box of 6 crayons. Then she bought 3 more boxes. How many crayons did she buy in all? How much money did she spend in all? Well, first of all, to figure out how many crayons, well, there's 6 in each of the groups, right? So I would say 6, and 6, and 6, and 6. Now I would have to add those together. That's kind of the hard part, right? 6 and 6 is 12. 6 and 6 is 12 again. Hopefully you know that 12 and 12 is 24. So it'd be 24 crayons. And since each of them is $2, I could just say 2 plus 2 plus 2 plus 2, right? And that would equal 2, 4, 6, $8. Okay? So that's what we're focusing mostly on. For your assignment, you're going to do a lot of the similar things. Over here, it says draw a model to find the total number. So on page 197, this is part of your assignment, I want you to actually draw a model that shows 2 groups that has 8 in each group. If you want to put a little line here, you can, because some people, when they read it like this. 2 groups of 8 equals. No, it's supposed to be this. 2 groups of 8 equals, and I kind of wish they would just use the equal sign because it would make a little more sense. Okay? So make a picture of all those. On this one, remember, 6 times 4 is actually 6 groups of 4. And this is 4 groups of 8. So make sure your picture shows that, because I am going to be particular about those pictures. On the next page of the assignment, it says describe each set of equal groups. So here's your set. Tell me, what would the addition problem be? And then how many groups and how many in each group? Okay. Same with the stars. Then same with this. Tell me how many groups, how many in each group for the problem. 6 times 5 and 3 times 4. And then you're going to do similar things for a couple of word problems. And then there's a little bit of vocabulary, and you can use the pages we were on to do that. So for your assignment, pages 197 and 198, and I will see you tomorrow live for math.